Good evening, student. How are you? Fine. Oh, that's good. And today I am going to discuss something about metals and non-metals. But before that, we should have little conception regarding some other things, such as matter, element, compound, mixture, etc., etc. Okay? Are you ready? Oh, then let's start. First of all, you come to matter. Matter. What is matter? Anything that has mass and occupies space is matter. Okay? Anything that has mass and occupies space is matter. Okay, to understand this point, first you take one example. I have this piece of stone, and if you lift it, and easily you can understand that it has mass. Is it? And what is mass? The actual matter present in a body is called mass of the body. Okay? The actual matter present in a body is called the mass of the body. To get the clear conception, you take one example. Can you tell me which one is heavier? 1 kg iron and 1 kg cotton. Among these two, which one is heavier? No. Both are same. Both of them are equally heavier. Okay? But difference is there in volumes. The volume of 1 kg cotton is more than the volume of 1 kg iron. Okay? Now, here you see, in case of iron, the actual matter is concentrated in a smaller volume. But here, in case of cotton, the actual matter is scattered, occupying more space. Okay? So, the volume of 1 kg cotton is more than the volume of 1 kg iron. But both of them have equal mass. Clear? You take another example. Now you see, this bottle is full of water. Okay? And its volume is 500 ml. Or in other words, you can see that the volume is 500 centimeter cube or cubic centimeter. Okay? Clear? And its mass, it is also almost 500 gram. And again, what is there inside the bottle? No, it is not empty. It is not empty. It is full of air. And how much its volume? Its volume is also 500 cubic centimeter. Okay. Now we think about the mass of this air. The mass of this air is negligible as compared to the mass of water. But their volume are same. Okay? Clear? And difference is only in their masses. Clear? Why? Here the water particles, afterwards I will tell that molecules, the water particles, these are closer as compared to the particles of air. Okay? Means here the air particles are scattered, occupying a huge space as compared to the water. Okay? So, I think it is clear about the mass. Mass is the actual matter present in the object. Okay, mass is the actual matter present in the object. Clear? Now you come to another term, that is space. Now again you take another example. This glass is empty. Let me pour some water here. Okay. Now the glass is full of water. Is there any visible empty space? No. There is no visible empty space. Now let me put this stone inside the water. Okay. Now you see. What happened? As soon as the stone goes inside the water, there is overflow of water. Okay? This stone displaces some water which is equal to the volume of the stone. It proves that the stone occupies space. Is it clear? So once again, then what is matter? Anything that has mass. Okay, that has mass and occupies space. Clear? Anything that has mass and occupies space is the matter. As for example, the stone, it has mass and it is occupying space. So it is matter. Okay. Now, I have also definite mass. And I am also occupying certain space, and due to this my figure along with this huge stomach. Am I right? Okay. So according to the definition of matter, that which has mass and occupies space is the matter. So I am also matter. Am I? Yes, I am also matter. But I am living matter. Okay. I am living matter. Not only myself, you are also living matter. Plants are also living matter. And microorganisms are also living matter. Okay. Although they are not visible to our naked eyes, as they are very minute, but they have mass and they also occupy space. So they are also matter. Okay, but all these are living matter. Clear? And I have so many different things here. The salt, the stones, and the hammer. All these are also matter. Why? Because it has also definite mass. It is also occupying subspace. Clear? So now I can conclude that those things which has physical existence are the matter. Okay? Those things which has physical existence, we can feel, we can touch, and we can measure their physical quantities such as mass, volume, density. Okay? All these are matter. Okay? Clear? But there are some other things. Simply we can feel it. We can imagine it. But they don't have any physical existence. And they are not matter. As for example, love, angry, imagination. We cannot measure this. Okay? We cannot measure this. Can you tell that you have 100 kg love for your parents, and his amount of angriness is 200 gram? Can we tell like this? No. We cannot measure them. We cannot tell these things this way. How much you love your parents? This much? No. You love your parents this much. Because they are your well-wisher. They sacrifice their everything for your happiness and bright future. Okay? So you should love them, you should respect them, and you should obey them. Then only you will get great satisfaction. Okay? Now again come back to our point. So we can classify the matters broadly into two groups. Okay? Matter broadly we can classify into two groups, that is living matter and non-living matter. Non-living matter. Okay? So broadly we can classify matters into two groups, that is living matter and non-living matter. And what are the living matter? Then animals. Animals are living matter, and you know that plants are also living matter, and then microorganisms are also living matter. Clear? And these are living matters. Okay? And we will discuss about living matters afterwards. And for the timing, you come to the non-living matter. Now we see, I have so many different things here. I have this soil, water, air, this mustard oil, the hammer, knife. I have so many different things. But the characteristics, behavior, and composition of all these different things are also different. Okay, so these non-living matters also classified into three groups depending upon their behavior, characteristics, and composition. Clear? And what are those? That is elements, then compounds, then mixer. Okay? Then mixer. Clear? The non-living matters are broadly classified into three groups, that is element, compound, and mixer. Okay? Why they are classified into three groups? Because these three individual groups have different properties from each other. Okay, among the elements there are some common properties. Among the compounds they have their common properties, and among the mixers also they have common properties. But there are vast or distinguished differences between between element and compound and mixer, or element and mixer. Okay, I think it is clear. You forget about this living matters. Now we will discuss about these non-living matters. Okay, so first of all you come to the element. Okay, then you come to element. Okay, what are elements? Elements are the substances which contain same kind of atoms. Now there is again one problem. First of all you should know what is atom. Okay, then what is molecule. Then only you will get the clear conception regarding elements, compound, etc. Okay, then for the timing you will just remember what are atoms. Okay, actually atoms are the smallest particle of elements. Okay, and atoms are the smallest particle which take part in chemical reaction but may or may not have independent existence. Clear? Atoms are the smallest particles which take part in chemical reactions and may or may not have independent existence. Here, those atoms which are stable, they never take part in chemical reactions and they have independent existence. Could you follow the point? There are some cases, that is helium, neon, argon, krypton, radon and xenon, and they are stable and they never take part in chemical reactions. Okay, so they have independent existence as atom. Okay, but except these, other atoms are unstable. Okay, so they immediately combine with among themselves, means same kind of atoms or other atoms to form molecules. Clear? Okay, and we will discuss these things, why the atoms are unstable and why these atoms are stable. Okay, and whenever we will discuss about the electronic configuration, then I will talk about that. Okay, for the timing, you remember that except these few atoms of certain elements, okay, and all other atoms are unstable. That is why they immediately take part in chemical reactions. Okay, they combine with atoms of same element or atoms of other elements to form molecules. Is it clear? Okay, then at the same time we remember about molecules also. Okay, then molecules are the smallest particles which have independent existence. Okay, molecules are the smallest particles which have independent existence. Okay, clear? And molecules are formed by the combination of atoms of same element or atoms of different elements with the help of chemical bonds. Okay, and how are molecules formed? Molecules are formed by the combination of atoms of same element. Atoms of same element. Suppose this is one atom of oxygen. When this atom combined with another atom of oxygen, it will form one molecule of oxygen. Okay. On the other hand, when two atoms of hydrogen combine with one atom of oxygen, then it will form one molecule of water. Okay. Then how are molecules formed? Molecules are formed by the combination of atoms of same element or atoms of different elements with the help of chemical bond. Okay, and the molecules have their independent existence. Okay, so we can conclude that molecules are the smallest particles of elements or compound which have independent existence. Okay, clear? Okay, then again come back to our topic, that is element. So what are elements? Elements are the substances which contain same kinds of atoms. As for example, you say oxygen. In oxygen, you will get only the atoms of oxygen. Okay. In oxygen, you will get only the atoms of oxygen. Similarly, nitrogen. In nitrogen, you will get only the atoms of nitrogen. Okay, in iron, you will get only the atoms of iron. In copper, you will get only the atoms of copper. Okay, clear? But in case of compounds, you will get atoms of different elements. Now, try to get the differences between atoms of between the elements and compounds at the same time. Okay. Now, in compound, you will get the atoms of different elements. Okay. Then how is compound formed? Compound is formed by the chemical combination of atoms of different elements with the help of chemical bond. Is it clear now? Okay. Suppose carbon dioxide. Carbon dioxide. In carbon dioxide, there are two different types of atoms. Atom of carbon and atoms of oxygen. Okay. In glucose, you see, in glucose, there are three different types of atoms. Atom of carbon, atoms of hydrogen and atoms of oxygen. Okay. So, here we can conclude that compounds are the substance, okay, which contain atoms of different elements which are bound chemically. Okay, clear? And another important point here you remember, in a compound, although there are atoms of different elements, but the atoms of different elements have lost their own properties in the compound. Okay, and they together show a new property. As for example, you see, hydrogen, when hydrogen combined with oxygen, then the water molecules are formed. And already I mentioned that the atoms do not have their independent existence. So immediately they combine to form molecules. So whenever we write the chemical equations, we generally write these gaseous molecules in their molecular form. Okay. Now, so for the timing you forget about these two, etc. Okay. Simply you remember these things only. Now you see, these are called reactants. These substances which react, means these substances which take part in chemical reaction are called reactants. And these substances, here one substance is produced, but in some chemical reaction there may be two or more different substances. Okay, now you remember that this is called product. Okay, now here hydrogen has its own properties, oxygen has its own properties. Okay, but after the chemical combination in water, the hydrogen as well as oxygen have lost their own properties, and water shows totally different properties from hydrogen and oxygen. Okay, you know that hydrogen burn itself, oxygen helps in burning, but water put off burning. Okay, clear? So, and another important point you remember, from a compound we cannot easily separate the constituent elements. Okay, from a compound we easily cannot separate the constituent substances. Could you follow me? Okay, good. Then mixture. Then mixture. What is mixture? Whenever two or more different substances are mixed physically, then we get a mixture. Okay. Here one point you remember, that is the physical mixing. There should not be any chemical reaction among the substances which are mixed. Okay. If there will be chemical reaction among the substances, then they will form compound, not mixture. Okay, clear? Now suppose here you see this dal. There are so many different types of pulse crop, like green gram, black gram, lentil, and all these things are simply mixed physically. There is no chemical reaction among themselves. So we can say that this is also a mixer. Okay, this is also a mixer. And again you see, this is soil. It is also mixer. Why it is mixer? Because here so many things are already mixed. There are some plant residue, there are some small stones, and there are some sand particles. Okay, and so many things are mixed here physically. So we can say that it is mixer. Okay, and again this air is also mixer. What? Because in air you will get varieties of gases like oxygen, hydrogen, nitrogen, carbon dioxide, water vapor, germ particles, dust, and these pollutant particles are also there. Okay, so it is simply a mixture because in air they are not reacting with each other. Now you think in air there is oxygen and hydrogen. If all oxygen and hydrogen combine and form water, then what will happen? It is not happening. Okay, not that they can react, but they can react under some special conditions. Okay, we'll discuss all these things afterward, step by step. Okay, for that I mean, you remember these things only, whatever I am talking about. Okay, now you see, again I am taking some water in this glass. Okay, let me mix some salt. Okay, I am mixing some salt. Then what it is? It is also a mixer. It is the mixture of salt and water. Okay, it is the mixture of salt and water. Now, let me mix some soil to this water. Okay. Okay, now you see here, this salt gradually disappearing. This salt is gradually disappearing. Whether someone has taken salt from here? No. Actually, what happened here? Once I mentioned you that water, it is also formed by so many water molecules. Okay, and the molecules have their attraction force among themselves. Okay, which keep them side by side. Okay, but there are some empty space in between the molecules of water. Okay, and this space is called intermolecular space. Okay, and whenever I put salt, first this salt itself break down to its molecular form and gradually occupy the intermolecular space of water. Okay, so it disappears. But here, and this type of mixture is called homogeneous mixture or uniform mixture. But here, this soil will not disappear, and moreover, this soil will settle at the bottom of the glass. Okay, means this soil will not mix uniformly with water. Okay, then also it is called mixture, but it is non-uniform or heterogeneous mixture. Okay, and similarly, if I put some oil here, the oil will float over water. Okay, clear? The oil will not mix uniformly with water. Then also it is called mixer. Okay, and another important point you remember, from a mixer we can easily separate the constituent substances. Suppose from this mixture of different pulse crops, easily we can separate this lentil, green gum, black gum, isn't it? And suppose from the mixture of this salt and water, if you want to get back the salt, simply you boil it. Water will evaporate and soil will left behind. Okay, clear? So you remember, this is the main differences between compound and mixture. Okay, the constituent substances of a mixture never react with each other. Okay, but a compound is formed due to the chemical reaction among the different substances. Okay, and from a mixture easily we can separate the constituent substances, but from a compound we cannot separate the constituent elements. Okay, and generally the compounds can be represented just by writing formula. Suppose water, instead of writing water in word, simply if we write H2O, then we will understand that this is one molecule of water. Okay, but to represent a mixture, we do not have this type of any formula. Okay, I think these things are clear to all of you. Then again come back to element. Okay, again come back to these elements. Now you see, we have so many different elements, such as iron, copper, aluminium, hydrogen, oxygen, nitrogen, carbon, sulfur, phosphorus, iodine. We have lots of different elements. Okay, but the characteristics of all the elements are not same. Okay, there are some common characteristics among some elements. Okay, and they are grouped together. And similarly, some other elements have so many common characters, and they are also grouped. Okay, clear? But there are vast differences in between them in different groups. Okay, so depending upon the similarities and differences among the different elements, they are classified into 3 groups. They are, that is, metal. Okay, then non-metals. Okay, then metalloid. Okay, these elements are classified into 3 groups, that is metals, non-metals and metalloids. Okay, clear? Now today I will discuss about some physical properties of metals and non-metals. Okay, now we will discuss some physical properties of metals and non-metals. Now think about some metals. Do you know? This iron, aluminium, and this copper wire. Okay, all these are what? These are metal. All of you know it. And non-metal like hydrogen, oxygen, nitrogen, carbon, sulfur, phosphorus, these are non-metals. Okay, if you know the characteristics of metal and non-metals, and you can easily identify them. Okay, so first let us discuss some their physical properties. Now you come to the physical state. It is this piece of iron. It is made up of iron. Tell me about its physical state. Is it liquid? Is it gas? No, it is solid. Okay, and this aluminium, it is also solid, isn't it? So you can say that metals exist in solid states. Okay, metal exists in solid states at normal temperature. Okay, clear? But inside the earth, still so many metals are in molten states because the temperature inside the earth is too high. Okay, but at normal condition, all metals are in solid state. There is one exception, that is mercury. Have you seen mercury? And it is used in thermometers. Okay, then you think about the non-metals. Just first you think about the examples. Which are the non-metals? Carbon. Here you see, this is wood circle. It is nothing but one allotropic form of carbon. Okay. Hydrogen, nitrogen, oxygen. You see, hydrogen, oxygen, nitrogen, they are in gaseous state. Okay. Then the carbon, sulfur, phosphorus, they are in solid state. Okay. So we can say that non-metals generally exist in solid and liquid state. Okay. There is one exception, that is bromine. It is liquid at normal temperature. Okay. So now we can say that metals exist in solid states. Exception mercury. And non-metals generally exist in solid and gaseous state. Exception bromine. Okay, then next point, hardness. It is soft or hard. Now you see, it is very hard, isn't it? So we can say metals are hard. But there are some exceptions. Lithium, sodium, potassium, they are the soft metal. We can cut them with the help of knife. Okay. Then you think about the non-metal. Suppose this piece of wood circle. If I hammer it, what will happen? It will break down into its powdery form. Means soft. Okay. So you can say that these solid non-metals are soft. And there is also one exception. That is diamond. Diamond is the hardest naturally occurring substance. But you don't think that a piece of diamond cannot be broken. Piece of diamond can be broken easily. But single crystal of diamond can't be broken easily. Okay? Clear? Then again we can conclude the second point this way. That metals are hard. Okay? Except alkali metal, that is lithium, sodium, potassium. Okay, but the solid non-metals are soft. Clear? Then you come to the melting and boiling point. Do you know what is melting point and what is boiling point? The temperature at which a particular substance melts is called the melting point of the substance. Okay? Suppose a particular substance melt at a temperature, let's say 100 degrees centigrade. Then the melting point of that substance is 100 degrees centigrade. Okay. Then you know ice converts to water at a temperature above 0 degree. Okay. It means that the melting point of ice, that is water, is 0 degree centigrade. And at 100 degrees centigrade, the water converts to its vapor state. Means boiling point is 100 degrees centigrade. Okay. So you remember that the temperature at which substance converts from liquid to vapor or gaseous state is called its boiling point. Okay. Now you come to the boiling and melting point of metals. If I keep it over the flame of our gas stove, whether it will melt? No, it won't melt. But if you keep it at a very high temperature, no, it will melt. What does it mean? It means that the melting point of metals are too high. Okay, as melting point is too high, and definitely boiling point will be more than that. After it melts, then only it will boil. Clear? Okay? So, you remember that melting and boiling points of metals are too high. Okay? And non-metals, you think about the non-metals. So many non-metals are still in gaseous form at normal temperature, such as oxygen, hydrogen, nitrogen. What does it mean? If you keep these gases at a very low temperature, that is in minus centigrade temperature, then these gaseous substances will convert to its liquid state. Again, if you decrease the temperature, it will convert to solid state. It means that the melting and boiling points of non-metals are very low. Is it clear? Okay. Then you come to another important property, that is the conductivity. Metals are good conductor of heat and electricity. Now, this sauce, it is made up of what? It is made up of aluminium. Not only this, our cooker and most of the cooking utensils are made up of aluminium. Why? Because these are good conductor of heat. Whenever we apply heat at the bottom, immediately heat transfer to the substances which are kept inside. So there is less wastage of heat. Okay, clear? So we can say that metals are good conductor of heat. Okay, again you think about your household conducting wares and the mainline conducting wares. These are made up of what? These are made up of copper or aluminium. Why? Because these are good conductor of electricity. Okay, but non-metals are poor conductor of heat and electricity. There is one exception, that is graphite. Your this pencil lead, it is made up of graphite. And graphite is nothing but one allotropic form of carbon. Okay, it is one allotropic form of carbon and it is good conductor of heat and electricity. Okay, clear? Then come to another property. Now you see, this knife, where from it is made of? It is made up of iron. And when a piece of iron is beaten with hammer, it is turned to flat shape. Okay, it means that by hammering metals, we can give it can be given any shape. Okay, if we hammer a piece of copper, piece of aluminium, we can make it sheet-like structure. You can convert it to a sheet-like structure. Am I right? Okay. And this property of metal is called malleability. And it is the unique property of metal by virtue of which metal can be given to a flat shape, like sheet-like structures, just by hammering. Okay, you see that most of the ornaments, these are made up of what? Gold, silver, platinum, etc. You think about these different designs, and it is possible only due to this property. Okay, but non-metals are non-malleable. And simply, if I hammer it, I can't make to a sheet-like structure. Simply, it will break down. Okay, clear? So, I can say that metals are malleable, but non-metals are non-malleable. Okay, again, we can draw some thread-like structure from metal. Suppose you think about these wires. This is aluminium, copper, whatever different wires we are using. These are simply thread-like structure, and these are drawn from metal. And it is also one unique property of metal. Okay, and this property is called ductility. Okay, clear? Ductility is the unique property of metal by virtue of which metal can be drawn into thread-like structures. Okay, so we can say that metals are ductile, but non-metals are non-ductile. Okay, clear? Then another important property, that is lustrous. Metals are lustrous. Means the surface of the metal are shining. The surfaces of the metals are shining. Now you see, it is not shining. Why? Because so many different things are over here. That's why it is not shining. But if I break it, the broken portion will be shining. Clear? Okay, so we can say that metals have metallic luster, means pure metals are shining. Okay, but non-metals do not have metallic luster except iodine. Clear? Okay, then another important property, that metals are sonorous, means when a piece of metal strikes on hard surface, it produces sound. As for example, you see, now sound is produced. Means metals are sonorous, but here no sound. Here different air molecules are there. Is there sound? Is there any sound? No, there is no sound. So we can say that metals are sonorous, but non-metals are non-sonorous. Okay, now you see, if we know these properties of metals and non-metals, if so many different metals and non-metals are mixed together, then also easily we can find out them. We can separate them. Okay, so you please try to understand. Don't try to remember. You please try to understand. Okay, then easily everything will be clear to you. Okay, and besides this, there are so many other properties also, but for the timing, you remember only these properties. Okay, best wishes to all of you. And in my next class, I will discuss about the chemical properties of metals and non-metals. Okay, and till then, bye bye. Take care. Okay.